Hello, I'm Florian. In this video I want to show you how you can measure DC biased impedance using the Bode100. But what does this mean, DC biased impedance measurement? Well, the impedance, Z, is the dynamic resistance at a special operating point. A resistor, for example, does not depend on the DC voltage that is applied to the resistor. It shows constant dynamic resistance. A capacitor can show different behavior. That means the impedance or dynamic resistance can strongly depend on the operating voltage. This is especially important if you design, for example, output filters of switch mode power supplies. You always need the capacitor value at the operation point, and we show how to measure this. We use the Bode100 in conjunction with the Picotest J2130A DC-Bias-Injektor. The setup is very simple. You connect the output of the Bode100 to the bias injector. The DC voltage is supplied by a DC power supply and directly connected to the DC bias injector. Our device on the test is then connected to the output of the bias injector. Our device on the test is a 100 microfarad X5R ceramic capacitor. I connect it to the DC bias injector with 0 volt DC bias applied. As a result, we see the capacitance curve over frequency. I want to measure the capacitance at 200 Hz. Activating a cursor leads to the result of 83 microfarad. I store the curve using the data to memory function and display data and memory. Now I add a DC bias voltage of 5 volts. The cursor value now reduces to 33 microfarads. This shows that the capacitance reduces with increasing DC bias voltage. For further measurement capabilities of the Bode100, visit our website at www.omicron-lab.com.